If you recall yesterday, we left off showing you a faster way to find equal fractions. We left off with a problem such as this: 3/5 equals something out of 20, and rather than go using the number line, we finished up the day by simply using our math facts knowledge, coming up with the fact that 5 times 4 equals 20. We're looking for a true statement here, and this is true. 5 times 4 equals 20. And whatever we do to the bottom, we learned we're also going to do to the top. 3 times 4, which is 12. 12/20 is then equal to 3/5. Well, today I'm going to show you quickly how I can prove that another way by using a multiplication table. I'm going to highlight our 3 row and our 5 row. The very first row you see here, which is 3 and 5, represents our 3/5. We multiplied 3/5 times 4. If we go down and look at our results of multiplying 3 and 5 times 4, we'll see the numerator is 12, which is what we had up here, and the denominator is 20, which is what we had down here. And if we follow those same guidelines, then it also holds true that everything in this top row and everything in the bottom row could be used as we move along the multiplication table, move to the 5s. Then 15/25 must also be equal to 3/5, and 18/30 must also be equal, and 21/35 must also be equal as we multiply by 7, and 24/40, and so on and so forth. And that is in fact true, that all of these are equal to what we originally started off with, which was 3/5. This 3/5 right here. So following that exact same guideline, any fraction, of course, it's 1 through 12, so you can use a multiplication table such as 2/8. You could simply go and highlight the 2's and the 8's in order to find, on this multiplication chart at least, 12 equal fractions. You could say that 2/8 is equal to 2/8, or you could say that 2/8 is equal to 4/16, 6/24, 8/32, 10/40, 12/48, 14/56, and so on all the way across. And the simple reality, the truth of it is, the reason why that works is because as you go across right to the right on a multiplication table, you're just simply multiplying both the top and bottom number, the 2 and the 8, by the exact same number. Multiplying by 2, multiplying by 3, 4, 5, 6. So as long as you do, and this comes back to the main principle again, as long as you multiply or do the same thing to both top and bottom, multiply or divide. You could also divide if possible, but as long as you multiply the top and bottom by the same number, you have an equal fraction. We'll be talking about how to divide by the same number, which is simply just the opposite, in order to make our fractions appear smaller, to reduce them. Here, and when we're multiplying, we're actually increasing the size of the digits, but the actual amount, the fraction itself, is exactly the same. In this next example, I'm going to show you another way, yet one more way, to find equivalent fractions. So here I have a fraction bar, and it's got 1, 2, 3, 4, 5 parts. So it takes 5 parts to make the entire whole thing. This equals, then, if we look at the shaded parts, there are 4 shaded. So this entire fraction bar is equal to 4/5 of the whole. So we're going to put equals 4/5 here. So if I were to ask you, how many 15ths is equal to 4/5? So 4/5 is equal to how many 15ths? So now you have a couple of strategies you could use already to solve this. And probably one of them is easier than this one, but here's another way you could think of it. So what you could do then is simply split this fraction bar again in all of its equal parts. We've done that before with number lines, and here we're going to do that one more time. Simply just split however many times we need to in order to create 15 equal parts, and we have 5 so far. So if I were to split these, how many times? Let's see if we split this. We split each one 3 times, a 3 split. 3 split here each time. That's 2 lines to 3 split. You can count them now. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 equal parts. That's what we were looking for. And now we can just simply count how many of those parts exist in the confines of 4/5. So this is our 4/5 here. So how many 15ths are within that? So we just count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And the total number there is 12. We could have done that, of course, with multiplication. There are 3 in each of these. We could have added them. Could have added each of these to get 12. We could have multiplied 3 times 4. There's many ways in order to calculate how many that is. You could have counted them as we did. So either way you look at that, it should be 12. That's how you could solve equivalent fractions with a number line. And remember that because that is a 3 split, that's also basically what you would have multiplied by. The split is the number you would multiply by. So we started with 4/5. We wanted to know how many 15ths that would be. We knew to 3 split this in order to get 15. That tells us that we should be multiplying both the numerator and denominator first there, of course, and the numerator by 3. That would have also got us 12. So your multiplier, this is called your multiplier, would have been 3.